And I started this community around in a couple of months back in February, and the aim for Scala India community was to curate and there's a Scala space in India since quite a while, but there was no dedicated Scala India community for the same. So that was the purpose of this community to ensure and nourish the Scala Scala space in India. And we have been doing Scala India talks since a while. And along with it, we are also writing, we have Scala India Medium blogs, and along with that, we have discussions going on, and we also have Summer of Scala Code 2025, where we are doing daily problem solving in Scala the functional way. So it will be great to have you all participate in that as well. Alongside that, we are always in searching for speakers for future Scala India talks. So feel free to in case you feel like giving one yourself in future, let me know. It would be great to have you. And today's session is on bridging the gap, how Scala can complement Python in GenAI production tech stack. So today we have Rajat Bhateja with us. He is data architect at Microsoft currently with over 14 years of experience. So he will take the session forward. And Rajat, are you there?
Yeah. Hi, Siddharth. Am I audible?
Yeah, yeah, you are audible.
Okay. Okay. So should we go ahead?
Yeah, I think
Uh,
you can turn your camera on and screen share and we can take
sure.
it forward.
Sure. Hi, folks. Thanks for joining in, especially on a Saturday afternoon. So I hope that this can be time valuable for you. So let's start. Let me share my screen and let me know once my screen is visible.
Yeah, your screen is visible.
Yeah, okay. Mm, yeah. Okay. So just make it full screen. Okay. Uh, I hope it's visible with a decent size. It's on full screen, right?
Yeah, your camera is not on in case you want to turn it on.
I did that. Is it okay now?
Yeah, great. You can take it forward. Thank you.
Okay, sure. Thanks, Siddharth, for the introduction. So let's jump into the topic. As Siddharth mentioned that we will be talking about bridging the gap, how Scala complements Python in production GenAI stack, right? Now, we have been hearing GenAI is advancing pretty rapidly, right? In fact, it is one of the most hottest topic of discussion in tech space, right? So it surrounds there, and we will see that how Scala can fit into that ecosystem, and not only fit in, how it can help, how Scala can be very useful in certain pieces, right? So we will dig into that. First of all, let's go through the agenda that we will be talking about. First of all, we will just have a very brief introduction about GenAI. It won't be a general introduction to GenAI, but primarily it will surround around the topics that we will be discussing about. Right. I hope GenAI everyone is aware of, so I won't get into a lot of details over there. Why this discussion is needed, that we will talk about. And then we will see that Python is a dominant language right now in AI space in general and in GenAI specifically. And but it does come with its own set of challenges. We will see the challenges that Python has right now and how Scala can overcome those challenges in some shape or form. Right, and then we will conclude, and then we will have a dedicated session, a dedicated time for Q&A. But feel free to ask any question in between whenever there is a logical break, right? I will try to give a small break in between the logical sections, and then also you can ask some questions if you have any. Yeah, okay. Let's start. Go to the generative AI. So as I've told that in today's rapidly advancing artificial intelligence landscape, generative AI stand out, right? Unlike a traditional AI paradigms where we are basically classifying or analyzing the data, GenAI possesses a unique capability to create the data. And data could be anything. It could be text, it could be code, it could be images, it could be anything, right? But it generates something. While traditional and traditional AI helps us analyze things, right? That's the basic difference between Gen AI and conventional AI. Now, if I talk about Gen AI, LLMs are the core of Gen AI as of now. LLMs and SLMs both. So basically, language models, be it SLMs or be it LLMs, especially when it comes to code generation and text generation. Yeah, examples being OpenAI's GPT series or Anthropic's Cloud or Mistral, and there are a lot more models which are coming up right now, right? So basically, LLMs are designed to understand, interpret, and generate human-like text, right? They can generate anything, as we discussed, uh, but there are certain specific requirements for an application to use LLM, right? So let's say you are building an application that uses LLM, it needs to have certain characteristics that it can handle, which is in line with the conventional application, but at a different scale, I would say, right? For example, handling large scale data. Now, handling large scale data is a must uh, thing to be there, because you will need a huge amount of data to enable LLMs to give you a better response, right? And it has to be in many scenarios it has to be real time. It has to be very consistent, right? And the pipeline supporting that has to be very efficient, as well as consistent, right, and robust. So, and then coming to model generalization, model that perform very well in POC. So that is a very specific problem we are facing right now, that models which are very performant in POC setup, when we take it to production, they start facing a lot of issues. A Sometimes in POCs we don't train the models with the huge amount of proper data, like production data. Moreover, there can be a scalability issue, performance issues that come when we actually take the models to production and use them on the data amount of data that it should be used on. Right, so that is another problem we face, that we are not able to generalize all the models that are performing well in POC to the production thing. Right now, dealing with concept drift, again, this is that over a period of time the data and the model starts to drift. Now, all of these are not the problems that Python has or Scala has. Some of them are design problems, some of them are still topic of research, and things are going on as a concept level, right? But some of them can be solved by Scala to an extent, and we will see which of them we can probably solve. And now, coming to scalable infrastructure. So as we talked that LLM models deal with huge amount of data, and they need a scalable infrastructure to support that, right? And then monitoring and observability is a very self explanatory term, and then security and ethical consideration. Now, this is very important, as LLM models generally would be autonomous, and they're getting more autonomous with agents coming in along, right? It is of very paramount importance that authentication, authorization, data encryption, secure communication protocols, vulnerability management, these things are ensured with these autonomous agents, right? Moreover, the ethical principles are very important in this scenario, because uh, over a period of time human intervention will go less and less. So we need to make sure that there are ethical checks and balances, which avoid biases, which promote fairness, transparency, and explainability to the outcomes that the models would be giving, right? So in general, with all these factors, the Gen AI stack has to be scalable, robust, compliant, and secure, right? Now, why the discussion, right? As I mentioned, not everything can be solved by just language. Some of them are still design and research problems, where people are working to find different patterns to solve some of the problems that Gen AI stack presents, right? But there are some problems that we can solve by the tech stack that we are using. Uh, Three of them would be reliability, scalability, and maintainability. Now, the thing is that Python dominates artificial intelligence and machine learning landscape, and for a very good reason. It's not stemming from. It's just not just like that, right? It stems from a very good reason. Python has very clear and intuitive syntax. Especially, it has an extensive array of libraries like Python, pandas, NumPy, scikit-learn, and so on. So that basically makes it a very popular choice among data scientists who are not very well versed with data engineering principle or engineering principles as such, right? So for them, it becomes a very important tool which they can use to quickly prototype and test data pipelines, right? And that is why Python excels, because you will get a lot of boilerplate codes which is sitting over there. A lot of libraries are there, and the libraries are generally very easy to use. It has a dynamic typing, so you really don't have to worry about setting up a lot of data types and yeah, in general, it's a very easy to use language, which can be used by non-engineers also to quickly test out something. And with the advancement of GenAI, the speed at which we can test out and we can prove our POCs is of paramount importance, and that is why Python has gained a lot of importance, right? However, the moment we talk about transitioning from proof of concept to a production ready Gen AI scenario, right? That is where Python generally doesn't perform very well. And it struggles with scalability, it struggles with reliability, and it struggles with maintainability. And we will double click all of these three sections in some of the slides going forward, right? Now, goal of this session is to explore that how can Python and Scala complement each other, because both languages have their own strengths and both languages have their own limitations, right? So, but how can they complement each other for the end-to-end scenario that we can take to production and make it add value to the users who are using it, right? Uh, yeah. Any questions till now? Like, is the agenda of the session clear? What are we going to talk about? Is that clear? Any questions till now? Or were you expecting anything else? Feel free, if I can add, I will try to include that topic as well. Okay, I would
I
take
think
it.
we are good to go.
Yeah, yeah. Okay. So let's move to the landscape, current landscape in AI development, which is where Python dominates. Right now, Python has become a de facto language in AI and machine learning. And as I said, that widespread adoption isn't accidental. It stems from a very key strength, and which perfectly align demand of data science and AI research, right? And some of the strengths that we will talk about is, first of all, it has vast ecosystem of libraries and toolkits. Now, if you talk about libraries, even if I talk about OpenAI, like frameworks like LangChain, LangGraph, they all come in Python for sure. There might be some other languages, but Python is the language in which every framework will come first. And that is why, like, be it pandas, be it numpy, be it scikit-learn, these all frameworks are available in Python, and including all the new frameworks which are supporting GenAI scenarios, they are libraries, so they are available in Python. So the breadth of libraries that is available in Python is huge, right? Another thing, if I talk about particularly deep learning, right? Deep learning is where PyTorch is a de facto framework. So right now we are not even close to anything PyTorch or TensorFlow in anywhere else, right? Which is Python native. So again, in space of uh, AI machine learning, and more importantly, it's very fast to take your idea to some working prototype, right? So that journey is very quick in Python, right? So, but that's not it, right? So if you talk about Python, it has its own challenges. Now we will double click into the challenges that Python brings out. First of all, performance bottlenecks, right? Now, Python does provide a clear and intuitive syntax, but that itself sometimes becomes the performance bottleneck also. So first of all, it is an interpreted language. Sorry, it's an interpreted language, right? Now, interpreted language, it has its own set of benefits, that it is very easy to test out a certain syntax, but at the same time, it is not recommended for a performance standpoint. The speed of execution of a compiled language can never be compared with an interpreted language, right? Uh, just a minute. Yeah. So Python can exhibit a slower execution speeds compared to any interpreted language, any JVM supported language, be it Java or Scala. This particular problem becomes a very noticeable problem when we talk about resource intensive processing. That is a must have when we talk about any AI scenario, whether it's GenAI or not. The data that it has to process has is of enormous scale, and especially in case of GenAI, the data that any application or even the core models have to process is of immense scale. And uh, being a non-performant language in those scenarios is of very it's a very restrictive space to be in. And one of the example that you can see is in PySpark. Now, Spark is a native Scala library, but it does support PySpark. And over the period of time, PySpark has gained a lot of performance advantages. So it has mitigated the advantages that Scala had, but not completely, right? So PySpark still access Spark through Py4j, and that means there is a process of serialization and inter-process communication that delays the performance, that delays the slow down the performance of Python as compared to Scala, which is natively calling Spark, right? So that becomes a very important problem, especially in case of production. So for POC, you are testing out with few MBs, few GBs of data, it works well. But when it comes to production, where you have to process hundreds of GBs or even certain terabytes or maybe even petabyte of data, this becomes a very critical bottleneck for Python. And every call might get every retraining first of all will get delayed, and then every call will get delayed in case of LLMs, right, which is not what users would expect. Another problem that comes with Python is global interpreter lock, right? Now, Python doesn't have a native multi-threading application or a multi-processing application. Python doesn't support something like Akka in Scala, which is natively multiprocessing, right? Every actor you can have a standalone process and it will run in silo. It can be it's a independent thing in itself, right? And you can run multiple actors. Python doesn't have a pattern like that. Python does support pseudo threading or multiprocessing to an extent, but then it run into problems like Python's global interpret GIL is what we know as, right? It is a significant constraint, and it shows that only one thread can execute Python's bytecode at a time, even on a multi-core processor, right? This restricts true multi-threading for a CPU-bound task, limiting ability to for the application of high concurrency, right? Which is a specific need when it comes to LLM. So think about that: you are creating a chatbot and you are getting multiple calls at a time, or let's say there is an agent which is going through multiple tickets at a time and summarizing them and probably suggesting uh, certain responses for each ticket. Now, if I have to process everything together, uh, this GIL will become a problem because Python doesn't support natively multi-threading or multi-processing application. I won't be able to process every ticket together. There would be some pseudo multi-threading I can do, but at the end of the day, it will still be one process running at a CPU, right? So any CPU-bound task, there would be severe restrictions when it comes to um, Python, right? So that is another concurrency, which is a very critical need in case of LLM applications, is not greatly or natively supported by Python. Now, as I mentioned, Python does provide a dynamic typecasting, which is very good when you are when uh, person wants to quickly write something, a quick and dirty script to test out certain scenarios, but that itself is a problem when we want to maintain the code, right? When we want to run the code in the production. So while again, it provides flexibility, but when the project becomes very large, when the projects become very complex, static typing of Scala takes the edge in maintainability and writing the code. Type related errors are definitely not, and moreover, this becomes a problem because these type related problems will not be caught until the runtime because of Python being an interpreted language. So you will have to wait uh, for the runtime to identify the problem. So this complicates it further. You can definitely make mistakes because of dynamic typing, and then you won't catch that mistake till the time you hit the runtime, right? Which means the developer cycle will get long and long, especially when the project or code bases are huge, when the projects are complicated, you are having multiple agents talking to each other. In those scenarios, this becomes even a major problem, right? Uh, yeah. So these are the some challenges that Python generally faces, and now we will see how Scala can overcome certain challenges for this, right? Now, if I talk about Scala, Scala has exact. So what I've tried is map exact 3 points to Scala's 3 points. So where Python struggles is performance, whereas Scala has that as an advantage. Scala is by nature a high performance language. Scala excels in delivering high performances and seamless scalability, making it an ideal choice for resource intensive demands, which is a useful thing in generative AI. It is inherently supported towards distributed computing like Spark, where the IPCs are causing problem when I'm calling PySpark. Scala has very less interprocess. Yeah, it has very low interprocess metadata. Right, IPC overhead is very low. Uh, so this helps you in processing multiple a very large scale data with much less time, right? And especially if you're into training LLMs, you can train a model on multiple nodes very efficiently because Scala is by nature is by nature created for distributed computing, right? So you can take the advantages of multiple nodes. This capability ensures that AI applications can handle increasingly data volumes, user load without compromising speed and responsiveness. Robustness and reliability, right? So Scala has a very strong type system, which can be a very not very, but yeah, it can be a slightly. It has its own learning curve. It has its own complexity in writing. I would not even call it complexity, but yeah, it has its own rules that we need to follow while writing the code. But that uh, takes a certain level of flexibility, but at the same time it gives you significant advantage when you want to run the code because typecasting errors won't be coming into picture, and even if they are going to come, they are going to come before it runs the runtime. You will be able to identify and rectify these errors at the compile time itself because it's a compiled language, right? This minimizes runtime failures and unexpected behaviors of these type errors. This ensures stable and predictable operation of critical AI services. It increases code readability, and it does support complex data types natively. So that makes an excellent choice when it comes to robustness and reliability. And moreover, it supports distributed computing, as I talked about earlier, which means that if something fails, there would be other node which will be running. And we will double click all of these three factors in a bit, right? And then developer efficiency and productivity. Now, Scala has its own learning curve, but once you learn it, right, it gives you very neat and clean syntax, right? It has a very concise syntax. It has very powerful abstraction. This allows engineers to integrate a lot of logic with very fewer line of code. which makes code maintainable, right? It has sophisticated concurrency model. Example like Akka is one of them. And this means faster development cycles, more maintainable code bases, and ultimately more streamlined and productive environment, right? So now if I double click into high performance, why Scala is high performance as compared to Python? So first of all, JVM integration. Uh, so Scala is a JVM language, which means that it has a very high performance and efficient memory management. It has strong type casting system, and it is generally faster as compared to an interpreted language. Right now, think about you're orchestrating a SLM call, a small or maybe a small LLM interfaces call, right? And each call that you are making, and again, this is very important when you are talking about multi-agent system, which is going to be the most important paradigm going forward, right? Because we are moving from a single monolithic call to a LLM to do a lot of tasks. We are moving towards multi-agent or a multi-LLM call paradigm where we make even in single so let's say we are passing one prompt to an application. Now behind the scenes that application might be making 4 or 5 different calls to 4 or 5 different agents or 4 or 5 different tools, and then one call just to compose everything together and return back to me. Right now, if each call adds certain latency, which it will in case of Python, against Scala, uh, the total response time, the total turnaround time for that application would make a huge difference, even the smallest of delays. Right, so that is where that GVM integration, jet optimizations, reducing latency would be critical in case of production application. For demo purposes, Python is fine, no arguments over there. But when I talk about because a few second difference in POC would be acceptable, but even few millisecond difference in production application might not be acceptable, would not be acceptable. Right. Now coming to Spark, Scala is native to Spark. Spark is natively written in Scala, which means even though again PySpark has been gaining advantage, not advantage, has been reducing the gap with Scala, but by virtue of being written in Scala, Spark provides more compatibility, better compatibility with Scala than it will ever do with Python. Some of the data types are not even available in Python. For example, data sets. If I talk about Spark data sets, they can never be called in Python, but they can be called in Java because Java is Java Scala. Scala is a strongly typed language, hence you can have a better control over Spark, right? Now, again, let's say you're building a document which has billions of records. Now, if you want to create embeddings out of those all documents, this process you can do very easily on a Scala, a Spark-based distributed system. Then, if you want to do it on a even Spark-based system using PySpark, there would be a performance difference. And if you use non-Spark Python, then the difference would be even huge because you won't be able to take the advantage of distributed computing that is provided by Spark itself, right? Again, coming to lazy collections and memory efficiency. So Scala provides lazy computation like iterators and view. They defer the computation until it's needed. This avoid full materialization of huge data sets in memory, right? Which effectively means that you can process huge amount of data sets, um, uh, yeah, in essence, infinite amount of data sets without getting open out of memory errors. Right, or at least getting mitigating out of memory errors to a large extent. Uh, yeah, and moreover, the actor-based distribution, right? So as I was talking, that if you talk about Ka, it provides actor-based distribution that each call that you are having will be a self-contained process, and that will run separately. That will run uh, in a multi-process, so you can run multiple actors, and they won't have to talk about. talk to each other. And even if, let's say, because of something it fails, it will run in isolated manner, right? And now even if one actor fails, it won't uh, it won't pass on that failure to other actors, and other actors can run in parallel without any difficulty. Even if, let's say, there is a one node which goes down, which is running number of actors, that node affects only those n number of actors, right? Other actors running on all the other nodes would run seamlessly. Yeah, was there a question? Okay.
I think
Okay.
the her mic is left
Sure.
unmuted. No worries,
uh,
you can continue.
but any questions still now?
Yeah, actually, I have a question.
Yeah.
Can you hear me?
Yeah, we can.
Yeah, I'm Debashish. Yeah, I do understand that Scala has lots of advantages with respect to
Mhm.
Python, but the market share says that PySpark has a significant advantage compared to Scala Spark, I think.
C- Correct.
And and also this performance thing is difference is getting narrowed through
Correct.
various support of efficient data serialization through Apache Arrow and things like that, which
Correct.
Python is getting. So,
Correct.
what are your observations on this?
Yeah. See, as I mentioned, you had rightly pointed out, with multiple optimizations coming in, PySpark is catching up to Scala, but it is
Right.
still not caught up 100%. And the market share gap that you are talking about is perfectly valid, right? Even if I see a lot of implementation that we have seen, what we have started doing is we use a lot of code which is sitting in PySpark. So any new developer comes in, they can write PySpark code. But
Right.
if you talk about my core frameworks, most of the times you will find that they are written in Scala, because that is where I need low level optimizations, which are okay. With every version, that gap will get reduced, it will get reduced further, but it will never catch up to Scala 100% by virtue of being written in natively in Scala, the Spark.
Yeah, but the performance difference is getting narrower. But on the other hand, Python has exposure to a huge ecosystem of libraries, as you mentioned, right?
Correct,
So it's
correct,
always for a data science user, it's always easier to write Python code than Scala code, right?
correct. And yeah, uh, I'm not debating that, right? That is where even what I was saying is that if you talk about very quick and very quick turnaround time, by because it first of all it's very easy to learn for a non-engineer. To learn Python, it's very easy, but it's has it Scala has its own learning curve,
Yeah, yeah,
especially for
that's
non-engineer
true.
who are
Yeah, yeah, yeah,
right.
sure.
So
That's okay. That's fine.
uh,
No,
yeah,
I just wanted to know your observation on this. How do you see these two converging together,
y-
Python and Scala, as far as Spark is concerned?
uh, yeah. Python will continue to get better with every so Databricks is releasing more and more advanced, with this new version coming in. After ALE, we have a new optimizer, right? That optimizer reduces the gap even further,
Right,
right?
right, right.
But where Scala will always stay ahead is, suppose you want to do that low level optimization.
Yeah,
Now, if
some
you want,
niche
correct,
areas where you need Scala's type system, where you need
correct,
Scala's sophisticated concurrency mechanisms, effect systems, and things like that. Those
correct.
in those places, but those are quite lower down in the level of the stack, right? Those are
E-
for application, not
e-
for the
e-
general application developer.
Yeah, correct. And but Devaship, that particular thing will become very important when we talk about GenAI, because GenAI we are talking about processing of huge amount of data,
Right, right.
and especially the concurrency, because Python doesn't have a native multiprocessing concurrency capability, while Scala can do that. And when you talk about LLM application, generally the paradigm would be where you will be processing multiple calls at the same time. Again, especially in the case of agents. No, that is where Scala will always have edge of on Python in production systems, right? And I will converge to that.
Yeah, yeah,
I will
sure, sure,
come
sure. Okay.
because the entire point of this presentation is that I'm not saying that one language is above another language, but what we will be concluding is that they are complementing each other, and how,
Right.
that
You
is why
need to
today I
have the
should.
synergy. Yeah, that's true.
Correct.
Okay. Thank you. Thank you. Thanks.
Yeah. Okay. So let's move forward. Uh, right. So as we have discussed that robustness and reliability we have already discussed. It has strong type checking, immutable data structures, exhaustive pattern matching, and actor model supervision, which is what I was talking about. Especially when you talk about processing multiple calls in silo, maintaining context of each process in silo, in isolation, that is where patterns like active model supervisor becomes very critical, right? Okay. Again, we have discussed about this a lot, like concise and expressive syntax, powerful abstractions, robust concurrency, and strong type systems, and interpretability. That is again a very important system. And just on interpretability, that is where I see future developments will be happening. And I will talk about that in my concluding slide. Right. So now, if I compare both Scala and Python, it both have their own advantages. Both have their own disadvantages. Some excel in something, and some the other language excels in other thing. Right. So if I talk about performance, yes, Scala takes the edge because it has a minimal IPC overhead. Yes, developments are happening, especially in Python. In case of PySpark, where we are gaining, where the IPC delays are getting smaller and smaller, but the low level programming that you can do in Scala is still not available in Python, which is important when we talk about a huge scale of data or a very niche design pattern that I want to enable. Right? For a throwaway system, for a even for a decent production system, now PySpark is as performant in some of the scenarios as Scala also. Scalability again. If I talk about multiprocessing, Scala definitely has an edge because it is natively multi-threading. It supports multi-threading natively, while Python has its own challenges with GIL. Type safety, dynamically typed Python has its own flexibility advantage, but that flexibility leads to runtime errors, and which is prone to runtime errors, while Scala is statically typed and is compiled language, so you won't be running into errors a lot, and even if you do, they will be getting highlighted at the compile time. So that error at runtime would be few and far between, right? Ecosystem is definitely where Python excels, and that is why if you see LLMs generate a lot of code for Python, but they don't generate a lot of code for Scala. That being said, you can always use Java's ecosystem, which is not as good as Python, but it is still there. I mean, you will always have access to Java's ecosystem, right? Developer productivity. This is actually a debatable topic because probably engineers who have a good command on Scala will always prefer Scala because it gives you concise syntax. It gives you a very powerful pattern in which you can write complex code with very limited code, few line of code. But Python at the same time is very easy to learn, especially for folks who are not having a command on Scala. Right. So Python was and is my one of the first languages. So it's very easy to learn language, and it's very good for prototyping. And when I want to move fast and I want to prove a POC, Python is still my go-to language, and probably would be because whenever a new framework comes, it comes in Python first, right? So if you want to test out something quickly, Python would be the go-to language. For model and training, yeah. So if you are training model yourself, and you can enable distributed training, Scala will definitely give you an edge. While if you are using a model and you're fine tuning that model, you're passing an additional context to model, Python can still do the job. Right. So these are the things that differentiate them. Right now, if I talk about conclusion, uh, so what I have seen as of now is, so because there are not whole lot of enterprise level applications which are implemented in GenAI as of now. Most of them are POC or POC plus, like except for few enterprise applications, few chatbots, if I could say. There are very limited implementations, but Scala is gaining importance when I have to productionalize a system. But Python is the language where I want to test out, prototype, and prove the concept. Right, and that is where I see will be happening. So if you want to get into GenAI, you will have to learn Python for prototyping, for uh, proving your concept. Once you proved your concept, then for productionalizing, Scala has still a very great role to play, and it has its own set of advantages that we talked about. One problem that I have faced is now. Uh, Once you have proven the concept, you have to effectively refactor the code, not only refactor, rewrite the entire code in Scala to productionalize. That becomes a problem, right? So what I am seeing in future is that there would be options which will be coming, which will be better, which will be giving a Python JVM interpretability in some form. That way we will be able to test out something and then probably move it into production with a faster or an easier way, right? However, we are still not there, and till the time that happens, Scala or yeah, Scala would be probably go-to language because it is already tightly integrated with all our data systems, right? Yeah, that's about that. uh, any questions that you have, any thoughts?
Yeah, so for example, one thing I had in mind is that right now, if you have some POC, as you said, that it's a challenge that you migrate the whole code to
Mm-hmm.
Scala. But for example, if you for POC you have utilized something like LangChain or LangGraph, and you are shifting to Scala for production grade stuff, protection grade pipeline. So in that particular process, as you already have quite a lot of open source system, open source libraries and ecosystem for Python. So do companies have something inner source, so you write everything from scratch from the very beginning, or how, what's the like internally inside a company usually, how's that process?
Of moving from Python to
Python, yeah,
Scala.
yeah.
Yeah, so that is still a very nascent, I would say very nascent stage, because there are not a lot of out of the box libraries available that I can use in Scala for creating my agents or creating my RAG pipelines. So wherever it is written, it has to be written from scratch. Uh, yeah.
Hi, this is Roshan. I'm audible.
Yes, Roshan, you are.
Yeah, I have similar question like as Siddharth asked, right? When
Mm-hmm.
you do some POCs, right? You writing something using Python packages, right? For example, you write some deep learning things. For example, right?
Mm-hmm.
That is, for example, you use PyTorch, whatever. When you talk about you migrate this code to Scala, right, for the production, because we know we need a stable code in the production right now the scenario you don't find something, right, whatever you write in the Scala, right? So what it means, like when you rewrite, what does it means, like you are writing the whole your uh, I mean AI model, or like the pipeline that is basically complementing the AI, for example data pipelining or cleansing the
Mm-hmm.
data, whatever. Is it that, or you are rewriting the whole model AI in Scala?
No, no. So we are not talking about creating models over here, right? We are talking
Mhm.
about creating the applications which use LLMs to perform certain tasks. And for that, what you will have to write
Okay.
is the calls that you are making to LLMs, that you will have to write. The gap that will come is that LangChain gives certain functionalities out of the box, While for Scala, you don't have a lot of libraries which are doing it. When I say out of the box, for example, one of the library could be prompt formatting. Now, prompt formatter is a function that is provided by LangChain out of the box, which formats your prompt in certain format. Right now, since you have to pass that prompt to LLM. Through LangChain, you can do it very seamlessly, but from Scala side, you might have to write the code which is written in prompt formatter yourself, or we have to find. I mean, once we have that open source libraries created for Scala, that is where you can start using that. But we are not talking about training LLM models here, or even
Yes.
distilling, right?
Okay, so basically understanding is like the pipelines that feeds to your LLM model, that is basically right, or
Correct,
something else.
correct, correct, correct. Or let's say you are creating embeddings. If you talk about an LLM application, one is calling, right? So for example, you have to you have the local data sitting in your company. Now you want to add that data alongside LLM's knowledge base so that user can ask data specific to your company's data. Now, this company's data could be a lot of SharePoint documentation. Now, if you want to make this data usable for LLM calls, you convert this data into embeddings, which is basically you have to vectorize this data. Now, to
Mhm.
vectorize this data, there are certain functions that you can use, right? And now, this, if you do in Python, would not be able to leverage good distribution, while if you do vectorization functions libraries are already present in Scala. You can vectorize that in Scala, right? Now if you vectorize these huge billions of files or millions of files using Scala, you will be able to do it in a distributed manner at a faster pace,
Understood. Completely
right?
understood. And one more thing, like
Mhm.
what do you see? Like right now, everybody is using Spark for this, or is there any other options? Like you can use Kafka and you can write your streaming applications, right? That can also be distributed.
No,
So
so both have different purposes. Now Scala, Spark, you can use for batch. Actually Spark can does Spark streaming also,
mhm, mhm,
but more or less Spark, when I talk about these embeddings, so these embeddings you won't be creating in real time, right? uh, th- there can be a lambda pattern which is
mhm,
having one pipeline, the bigger chunk happening in batch mode using Spark. Then there is one a delta pipeline for real time information that is flowing in right now, right? Let's say daily delta that you are processing through
mhm.
Kafka or Spark streaming. That could be a pattern that can be written. I have not implemented it myself, right? But streaming is mostly used for real time messaging, right? When I am responding using my application in real time. So that is one scenario that I can think of in real time. But more or less, it's about creating that knowledge base in a batch mode using Spark.
Got it. Yeah, but because you added one, like you had one more point about the concurrence and everything, right? Like that we get the advantage from the Spark and Scala. So my point is like we have different libraries, like for example Geos, right, and other libraries that can you can use fibers to like create multiple, concurrency, right? So that will you can write small codes and readable and maintainable code using those libraries. So I'm just saying, what is the current scenario?
For
Every
which for what, Roshan?
the same, like you are saying like everybody right now using Spark, right? I'm just saying, I'm
Uh-huh.
just trying to understand what the current scenario. Everybody is still using Spark, or they are eyeing on different libraries to uh, for the
No,
Scala, because those are completely you can
for
get
see
advantage, right? For example.
for major heavy lifting of data, at least from what I have seen, Spark is still the go-to library,
Mhm, mhm.
right?
Okay.
The main primary reason for that could be because people are pretty comfortable with Spark now, right? Be it PySpark or even Scala. Um, Whereas, and as of now, it doesn't give you a lot of bottlenecks because it serves the purpose. So for heavy lifting of data, I think Spark is still go to library.
Got it. Thanks.
Yeah.
Any other question? Anyone?
Oh, yes. So Rajat, I'm thinking like if we are having some issues with the Python libraries and to overcome these, we can utilize the Scala over that, and we can just write a wrapper over it using Scala to just provide a better solution. Means just like the concurrency problem. Uh,
Wrapper over what, people? Sorry, I missed.
we can utilize Scala to propagate over the problems like the single thread problem with the Python, right? So
Mm-hmm.
we can write an application that will handle the workload and utilize the Python library uh, within a Scala so that we can handle handle the requests over
But
Python.
the
Like
moment you call a the moment you call Python library, uh,
yes, like
you will
we
again
can
get
we
into.
like we can utilize the advancement in Scala. Like we can have actors, so we can use them to process um, the Python work. Uh, Whatever we can do in Python, we can utilize and we can run it parallelly using Scala.
Yeah, but then each actor you would be loading it with
Yes,
good amount
definitely
of
it will have
code,
to.
right?
Yes, it will have to use. Each actor will perform over that library and will
Correct.
provide the functionality to
Correct.
remove that single threaded problem.
Correct. Correct. Yeah, that pattern can run, but yeah, we will have to test out whether that gives you a performance gain or not. Because then each actor would be a very heavily loaded thing,
Yes,
right?
definitely
And
that will. But if we can achieve that, will be a
mm,
better solution somewhat. And if we do optimization over that as well.
correct. Yeah, true. But why not create such libraries, right? In Scala, natively Scala. And you will start seeing JVM compatible libraries soon. Because the moment you start hitting into production applications, I see these libraries will start coming out.
Yes, means we either means someone we can take the initiative to just write
Yeah.
the similar libraries into Scala or
Scala, natively Scala. Yeah,
native Scala, right?
correct.
Thank you.
Thank you.
Any other question?
Yeah, hello. Can you hear me? I just have one question.
Yeah.
Am I? Yeah, my question more pertains to static typing versus dynamic typing. Like sometimes when I write code with Python, I just want, or with Scala, I just want types to just get out of the way, right?
You
And
want
sometimes
type.
in Scala,
Uh,
yeah, especially as a user who writes code. So what Scala 3 feature would be, would be sometimes better for these kind of situations here? My question is like, what kind of Scala 3? Why would I choose Scala for writing LLM pipelines? Is my question because you mentioned in your talk that the benefit of Scala is that you have access to the JVM. But my question was, what more about the grammar or the syntax of the language would be better useful for this kind of stuff? I hope I make sense.
uh, no, actually, your voice is very not very clear. If I can repeat, we are talking about how Scala syntax is better as compared to Python, and especially how static typing is better. Is that what you're asking?
No, okay. My question was, there are
Mm-hmm.
some problems when writing user-facing code when compared to Scala. I mean, when I write in Scala, there's problems compared to when I write in Python, especially with having to do conversations on vectors and matrices, stuff like that. So what kind of Scala 3 feature would benefit me the most here? compared to languages like Java or some other statically typed language on the JVM? Because you mentioned like JVM is a big part of why one should choose Scala, but I was hoping for an answer that talks more about the grammar of the language instead and some features of the language itself that would be helpful. I hope I made sense here.
It's actually to me your voice is breaking.
I
So
think so basically I think as far as I could have understood, he's talking about that what Scala features basically gives Scala an edge over other JVM
JVM
languages.
languages.
Is that something that you can think that what Scala what Scala grammar you're saying Scala features Scala provides which gives an edge? Is that what you're asking?
Yes, I hope my voice is fixed now. I had a
No, no,
faulty
no,
earphone.
much better, Prince.
Yeah,
Yeah, yeah.
yeah, I'm so sorry for the confusion or whatever. Sometimes
Mm.
the microphone is kind of weird. My question was essentially that sometimes when I write user facing code, we mentioned that how Scala is or specifically Spark is better.
Mhm.
I feel like it's better for the more of the library side of the code, where users would much prefer writing in Python, as Debussy said.
Mhm.
But I was wondering more about the user side. Sometimes the type system feels a bit clunky, especially when you do matrix transformations or when you say, for example, get the vectors or matrix. It feels a bit clunky. So,
For
what
Scala.
Scala 3 features? Yeah, what Scala 3 features would be better for this case, and why would I choose it over something like Java? Because you mentioned in your talk that one of the benefits of Scala are is runs on the JVM, so you get free multi-threading and concurrency. But what
Correct.
more about the language itself, not the implementation, would you or the grammar itself? What would feel like it's the ideal thing
Yeah.
to
So
write?
if you compare Scala against probably Java, you can still write limited code, and you can write the clunkiness. The clunkiness that you mentioned is a problem of Python or Scala, because Scala is not clunky, at least in my experience. Or is it?
Well, it is because any typed languages would feel clunky, at least for me here. And this is someone. It's not from my It's not that I'm uncomfortable with Scala. It's just that any type system that I feel would be clunky because it doesn't do dynamic conversions, for example.
Correct.
So that was the part that was felt
Okay.
clunky. No, but it's a very
So
smooth language.
yeah, let's break it down into two parts, right? So if you say, if you compare Scala against Python, right, you have to write, as you said, because you will have to specify all the data types and everything, because it's a by nature statically typed language. Now
Yeah.
that, yes, it is definitely a slightly more clunky, if I can use that word, as compared to Python. But that is the advantage. That is the advantage I was talking about. That being dynamic type language, right, gives you flexibility while you're writing the code. But when you're running the code, that becomes a problem. It the dynamic the typing errors you will get much more in Python as compared to Scala, right? Scala will give you pure types, which will save you from that type errors at the runtime, while Python will give you. So it's a trade-off that you are making. You're losing some flexibility at the time of writing the code, but at the same time you are gaining efficiency when you are running the code, right? Especially in case of very runtime intensive application, you won't get errors at runtime. And now, if you compare Scala with any other JVM language, I think Scala would be the most least clunky language, statically typed language, right? If I compare Scala with Java or any other JVM or even J Sharp and everything, it gives you very neat syntax, statically defining types. Uh, did I answer your question to an extent? Like,
Yeah,
yeah.
makes sense. Makes sense. I'm sorry for the audio delay. The part that I was hoping to look for was somewhere around given conversions, for example, to make the language feel better and not having to convert between one type to other. But regardless, you answered my question, and I'm very grateful for it. Thank you so much.
Thank you.
Thank you.
Just to add, in Scala, you don't need to specify the types. It's okay. Like it's similar if you compare Scala 3 with Python, it's it's a very relatable. Like whatever you write in Python, right? You don't specify type. In Scala 3 also, you don't need to specify. When in Scala 2, compiler automatically understands it. But
Yeah,
when
it infers
you
it.
exactly, so it will be it's an advantage I can say, because in Java you have to specify other languages, right? But in Scala it is a flexibility and it's more like expressive language. It's a you don't you'll find it better. Try to use Scala 3 mostly.
Oh yeah, thank you.
Well, thank you. Any other question? I think so. That's it. So thank you, Rajat. I think it was a great session and very insightful into something like which is very much, as we discussed, a domain which is very Python dominant. So getting to know a side where Scala can really be helpful and can enhance our workflows is like, thank you for it. Thank you for giving a very insightful perspective. And I think in case anyone wants to connect, as shown on the screen, you can connect with Rajat. Anything else, Rajat, you would like to add, or we can end?
No, that would be it. Thanks for giving me this opportunity. It was nice interacting with the community, and I hope
Yeah.
that I would have add some value to everybody's time. Yeah, thank you.
Yeah.
Thanks,
So
thanks everyone.
thank you everyone for joining in. And in case anyone would like to give a next Scala talk, or know someone who might be eligible for the same, let me know. We are always in search for speakers. And also, in case you want to contribute to the Scala India Medium page by writing any Scala on writing anything Scala related. So yeah, again, let me know. It would be great to have fellow contributors. We have other things going on in the server as well. For example, Scala, summer of Scala Core. So yeah, do check it out as well. And my class, thank you for joining in, everyone, and see you around. Bye bye.
Thanks.